In this video, I will explain what the half-life is and how it is used in physics. You will learn what half-life means and how it plays a role in different areas of science. The half-life is the time it takes for half of a given amount of a substance to decay. This time varies for different substances. In physics, it is often used to describe the decay rate of radioactive materials. The half-life is an important concept for understanding the progression of decay processes. For radioactive materials, the half-life describes how long it takes for half of the atoms of a substance to decay. Each radioactive material has its own half-life. These times can be very short or very long, depending on the substance. The half-life helps calculate and predict the point at which decay will occur. To calculate the half-life, you need to know how much of a substance is still present at a specific point in time. The formula for the half-life relates the initial amount to the remaining quantity. In many cases, the calculation can be done using a simple formula. This formula shows how long it takes for only half of a substance to remain. Radioactive isotopes are unstable atoms that change by the decay of their nuclei. The decay happens randomly, but the half-life indicates how quickly this process occurs on average. A well-known example of a radioactive isotope is uranium-238. Other isotopes, like carbon-14, also have their own half-life. Temperature can influence the half-life of chemical reactions. Typically, a higher temperature causes reactions to occur more quickly. However, for radioactive substances, temperature has no effect on the half-life. The decay process occurs independently of external conditions such as temperature. This makes the half-life in radioactivity especially reliable. In medicine, the half-life is used to understand the effects of radioactive substances. In nuclear medicine, radioactive isotopes are used to create images of the inside of the body. Knowing the half-life allows us to accurately calculate how long these substances remain in the body. This helps control the dosage and duration of their use. A well-known example of the application of the half-life is carbon dating. Here, the half-life of carbon-14 is used to determine the age of organic materials. Carbon-14 decays at a fixed half-life, which allows us to calculate the time of decay. This method is often used to determine the age of fossils or ancient objects. Knowledge of the half-life is also important in environmental protection. Radioactive substances that enter the environment have a specific half-life. It is essential to know this half-life to assess the impact on the environment and health. The half-life also helps determine how long a region might be affected by radioactive radiation. Chemical reactions involve the rearrangement of atoms and molecules. Unlike radioactivity, the decay of atoms in chemical reactions is not random. Chemical reactions do not have a half-life in the same sense as radioactive decay. However, the half-life in radioactivity describes the constant decay of atoms over time.